Hi folks, Will at LR Workshop. The Grenadier is going to have an ECU. And in this video I'm going to talk about how I think electronics can be made to be reliable and actually how they could be of benefit when operating in remote places.
Bloody hell, it's cold and dark in this country. I'll do the rest of this video inside.
Now, electronics themselves aren't necessarily unreliable. I'm going to talk about how I think electronics can be reliable and useful, given the fact that if you're building a new utility 4x4 to be used around the world, including Africa, it will have an ECU, and we want it to be as reliable as possible. History doesn't help here. When the TD5 came out with the Defender in 1998, our experience of computers was Windows 95 and 98. They crash now and then. The blue screen of death. You could lose 3 hours of work because you didn't save. Nowadays, when was the last time your computer fundamentally threw its toys out of the pram? You probably haven't experienced something like that for quite a long time. Now, this was the argument put to me by a Land Rover experience instructor when I was driving a Disco 4 on an experience day, and I said I preferred the 300 TDI. That was 10 years ago, and you know what? He's not wrong. So why can electronics in vehicles be unreliable? It's just another thing to go wrong, as my dad would say. Well, you've got a lot more components. They can go wrong. You've got sensors, wiring for the sensors, and maybe the ECU itself could go bad. I'm going to go through each of these things one at a time and unpack and see how we can make these things more reliable in the design. Wires, they tend to break more often than mechanical things. That's just what people's experiences have been. But it doesn't have to be like that. It's all about what you specify for the job it's supposed to do. Make the sensors really robust and IP67 rated if they're going to come into contact with really hot, dusty and wet environments. And then you can protect the wiring so that it doesn't abrade through and that it doesn't snap with fatigue. Let's take an example, right, with the Defender. The central locking and electric windows commonly fails on the Defenders that have those features. The wire that runs from the bulkhead to the door snaps because of the constant opening and closing of the door. Now, the wire used there is just automotive thin wall wiring cable. Is it possible to make a wire that can stand up to repeated flexing? Yes, it can. When was the last time your headphone cables snapped due to repeated flexing? It's just about choosing the right technology for the job. Let's think about sensors. What sensor would prevent a modern engine from running? Probably the crank position sensor. That's probably about it. Everything a sensor does mostly is there to optimise performance and efficiency or emissions. There's not many sensors that prevent the running of the vehicle. The thing is that modern cars have electronics for incompetent drivers. And there we have limp mode. Why do we have limp mode? Limp mode, the sensors do not cause limp mode. The manufacturers cause limp mode. The sensors are just doing what they do. So why do we have limp mode? Because drivers ignore warning lights. And it's also a great opportunity to get your customers back into your dealerships and enjoy your expensive coffee and soak up the brand values they've got plastered all over their walls. In reality, it's goddamn annoying. It's wasting my time when the vehicle could run fine, it's just not running at its optimal performance. Another example where electronics don't really have a good reputation for the rough stuff is that Land Rover themselves did not endorse the TD5 for those kind of environments. In Working in the Wild, Land Rover's Manual for Africa, it states on page 110, the following improvised repairs for diesel engines are not applicable to the TD5 and must under no circumstances be attempted for these engines. The electronic management system for the TD5 incorporates a Get You Home backup program which automatically cuts in the event of a main system's failure. Let's take a look at some of these things here. We've got the following only applies to diesel engines up to 300 TDI. Now, one of these examples, fair enough, lift pump, TD5 doesn't have a lift pump, but blocked fuel line. How is your software going to unblock a blocked fuel line? Or to put it another way, why does an electronically controlled engine prevent me from being able to unblock a fuel line using this method? This is an indication of the kind of mentality you get that comes with ECU controlled vehicles historically. That paragraph is basically giving you 2 fingers up and saying, don't worry, our software's going to get you home. That's so arrogant. The troubleshooting item here says, don't even attempt it on a TD5. You don't know what you're doing. It's run on computer magic. You haven't got a clue what you're doing. Why do you think that so many people perceive electronics to be so undesirable? Go to the dealer, it says. Dealers in the UK can be awful. Imagine what it's like thousands of miles away when you're trying to implement the standards and processes from an entirely different culture than where the business model was designed for by having dealerships. That's even if there is a dealer. The Land Rover dealer in Malawi didn't have any hint of Land Rovers being related to their dealership. In Ghana, there's a dealership, they destroyed a 300 TDI engine on the first service. And the dealer in Belize was just awful. It was quite common for a vehicle in these parts of the world to come out of a dealership worse than when it went in. So let's tackle my third point about unreliability of electronics. The ECU could go bad. It could go bad. 5 years rattling around in a hot, dusty environment. But why aren't ECUs off-the-shelf replaceable parts like brake pads? You know what I mean? Do you know how cheap electronics are these days? When ECU problems crop up, people send them away, possibly to other countries. They go in a postage bag and get sent off to be diagnosed, checked, and then they get sent back and told it's not the problem. I've read about people having to do that in New Zealand. Their vehicle's off the road for 2 weeks because they had to send the ECU somewhere. Why can't we have an ECU that's like 20 quid or 50 quid? We just have it on the shelf as just like a replaceable part to diagnose. And if we think there's a problem with the ECU, we just swap the ECU and check if it was. That's how we would do everything else. Now, I say ECUs can be a problem here, but the real problem is software. The ECUs here are hard-coded to the vehicle. The VIN number's in the ECU. Well, there's a practical reason. I mean, when they plug it in the dealership, they can check the vehicle against a database and check any updates it needs or recalls that need to be applied. I understand that. But why does the VIN need to be in the ECU? Why can't it be on a small bit of EEPROM plugged in somewhere else, buried in the dashboard? It's just another module. All that does is save the VIN number. The ECU then reads the VIN number when it needs it. The ECU is totally unconnected to that vehicle per se. It can be completely hot swappable. I said the real problem is not the ECUs, it's the software. Well, it's actually not the software. It's the software engineers. VW emission scandal, anyone? I've been a software engineer. I've worked with software engineers. Software engineers are idiots. And I mean that in the nicest possible way. They're fascinated by what they can do with software. And I've been guilty of it in the past as well. I don't trust software to do what's best for me as a user. Software generally in vehicles has been used as a business model, but a business model that doesn't really work when a Western company is selling a product to a different market. The thing about software is that it gets designed to abstract or take away control from users because software engineers love the challenge of being able to try to make decisions on behalf of humans, let this technology do the work. But just because they could, they didn't stop to think about whether they should. Many vehicles are built with the iPhone mentality. That people don't care how it works, they just want it to work. Maybe a few cool and quirky things along the way. You know, cars these days, they close the boot for you, they stop you when you're drifting out of lane, they cancel your indicators for you. They start the wipers when it rains, they fold your wing mirrors in, they parallel park for you. When did we get so lazy that we couldn't close our own bloody car boot? Software allows us to do that, and someone thought, yeah, we should do that. I built a lot of software for people that need software to get stuff done. I make software that does all the boring stuff, like combining data, processing, blah, blah, blah. But if there's a decision to be made, then I present that to the user. I get the user to make decisions. Humans are a lot better at making decisions than computers are. So I'd prefer not to have all these driver aids in a utility 4x4. You know, people call me an enthusiast. I guess I am. I enjoy driving. I like to take ownership of it. I like to improve my skills. Increased sensitivity of the throttle position sensor in low range? No thank you. Holding the revs high between gear changes like on the Puma? No thanks. Did you know that from 2002 onwards, the TD5 in a Defender has an anti-stall feature? It's quite easy to stall the TD5 when you're pulling away from stationary because you don't give it enough revs. People say you've got to drive it like a petrol, give it a load of revs. But if you pull away without the throttle, it won't stall. That feature is not written in any user manual, any workshop manual. It's not written down anywhere. I only learnt it from a Land Rover experienced instructor. A lot of people hate the TD5 for how easily it stalls, but here's what the software does. The throttle pedal cancels the anti-stall, right? So that's not what people would intuitively expect. You would expect it to prevent the vehicle stalling no matter what, if it was a true anti-stall. So they've got a feature that was never put in the user manual, and it doesn't cut in when people expect it to. Just get rid of it. It's software, but it's rubbish. Although actually, maybe you could put these things in there. But I would say that a lot of people who are interested in the Grenadier are probably Android and PC users like me. They want to tweak and fiddle with the settings. If I owned a new vehicle, modern vehicle, I'd probably want to turn all that shit off, to be honest. The single touch indicators you get on modern vehicles, they're quite nice, but who the hell decided that 3 indicator flashes was what I need as a driver? Software's hard-coded at 3 flashes because the software engineers think that they know what I want. If it's going to be there, let it be there, but let me choose how many I want. Let someone configure in settings what they want the software to do for them. So are electronics unreliable? Well, I think with robust wiring, relays, sensors and a swappable ECU, I don't think they would be. I mean, fair enough, it's an extra system, but as long as the software isn't buggy and it works with me as a driver, doesn't try and make decisions on my behalf, and if it does have extra features, it allows me to tweak, configure or turn them off, I don't think electronics is going to be a bad thing in a new utility 4x4 vehicle. It's a design decision. You can make good software, or you can make the same old rubbish that all other car manufacturers have put in their ECUs since ECUs became a thing. There we go, folks. That was part 1 of my argument on behalf of ECU controlled vehicles. I'd love to know your thoughts in the comments below. Stay tuned for part 2 coming soon, where I discuss taking electronically controlled 4x4s into remote places. Thanks for watching. Bye for now.